Hello, and this is the Destructive Wolf, and I am making a video on algebra because I know a lot of people have difficulty with this, and so I'm gonna have to awkwardly stand here. So everyone knows about polynomials, right? Because what polynomials are basically x squareds plus or minus an x, and then plus or minus a last number, which is c. In other words, it's ax plus bx plus c. Or minus, it can be anything, basically. So that is basically your polynomial beginning. So I'm going to start you off with basically making a polynomial from binomials. And binomials are two, just x plus or minus a number. And the x can contain any number with it. So it would be x plus b. That is a half of a binomial. Another half of it would complete an entire binomial. And two binomials complete one whole polynomial. I'm just going to call it poly, and this will just be bi. So that's basically what it's going to go out to. You're going to have the two binomials, and it's going to go into one polynomial. So I wish I had something better that I could erase with. Don't say anything along with me. Might have to do that in the future. So basically what I'm going to do is give you a bunch of examples, give you time to try and see if you can do it by yourself after giving you instructions on how to create a binomial from a polynomial and a polynomial from a binomial. So first off, we're going to start with the binomial to a polynomial. So I'm going to give a very basic beginning. X plus 1 times x plus 1. X plus 1 times x plus 1 will create a polynomial, because with a binomial you have to FOIL. This is a term that a lot of people have heard before. FOILing is not difficult, but it can confuse a lot of people sometimes, because you do have to distribute. This x will times with this 1, and this x will times with this x, as will it repeat with the other binomial doing the same thing. And you just times everything by everything. So it would come out to be this x times this x would equal x squared, because x times x equals x squared. If you times this x by this 1 over here, then you would get plus an x. But we have another one on this side right here that we have to times this x by. So you'd have to add another x to the equation. And then finally you do 1 times 1, which would equal 1. And then if you actually simplified this all out, it would equal x squared plus 2x plus 1. This is the complete polynomial that you would get from the binomial equation that I had just given you. So using the FOIL method, you can create polynomials. So now I'm going to, after I just teach you the instructions, I'm going to give you a pretty simple one to solve as well. I'm going to give you time to complete this one, and after I give you time, I'm going to show you how to complete it yourself. So first, I'll give you a pretty simple one. X plus 4 times x plus 2. I'll give you about 30 seconds to times that all out. I was not counting, so I don't know if that was 30 seconds. So I'm going to show you how to do this. What you want to do is, as I said before, you want to distribute, and I actually thought of a different way of showing you this. you'll do the x times the x times the 2, and then you'll do the 4 times the x, and then the 4 times the 2. That is distributing each number to each other number. And I said that kind of weird. So, first you'll do the x times the x, which would equal x squared, and then you would do, since it's all plus, you're not going to have any minuses yet. So, you'll have the x times the 2 now, which would make a 2x. And then you would have a 4 times this x, which would create a 4x. And then you'll have a 4 times this 2 over here, which would create a 8. And then if you add everything, variables together, then you'll come out with x squared plus 6x plus 8. And that would be your completed polynomial. So, I don't know if you got that, but hope you did. If you didn't, you can repeat the instructions and hopefully you'll find out what you did wrong there. So, now that I taught you how to do binomials to polynomials, now I'm going to show you how to make binomials out of polynomials. So I'm going to give a very simple one that I had done before. X squared plus 2x plus 1. Very simple one, and it's actually a double binomial because the binomial is the exact same thing. It's the one that I had done at the beginning of the video, and this binomial is actually very easy to distribute. It is x plus 1 and x plus 1. But why? The reason why it's x plus 1 and x plus 1 is because you're doing FOIL backwards. No, it is not LOIF. It's just not foiling. There is no real way to figure out how to do this except to do it in your head, at least to me. Unless if anyone else had found out a way to do it, then I really don't see another way that you could distribute it. So I'm going to give another example, and I'll show you how to factor that out. Now the thing is, if these numbers don't factor out nicely, then you're going to come up with a very crappy equation. So, yeah. 4x plus 3. Really easy one. So the way that you actually factor these out is whenever you do the binomial, you'll always have these two if it's an x squared. So you'll have to do x times x to equal x squared. Since there is no coefficient by the x, it is known as to be 1. So it's 1x. So there would be no numbers next to these x's in these binomials. So, which makes it a lot simpler than it would be. So, I'm pretty sure if you've already learned this before, you already know what you're supposed to do. You want to get, here is the hard part, you want to times two numbers at the end of the binomials that add up to this 3. You want to find basically the what numbers will times to 3. And the only thing here, since 3 is a prime number, is 3 times 1. So, that's all the choices that you have. But you have to figure out a way to make these two numbers sum up to equal 4. But that's really simple, because this 4 right here is what you're trying to sum up to. You want to make both of these numbers sum up to 4. So, a really simple way to do that, if you don't have a prime number, would be write out all the factors of your c. As I told you before, it would be ax plus bx plus c. So you would find all the factors of your c, write them out over there, and then you would find something that sums up to 4 and times to the c, 3 in this occasion. So, since we found that 3 plus 1 already equals 4, that really sums it all up for this binomial. It makes it very, very simple. Because you have no starting coefficient, so it's known to be 1, and these numbers are positive both. So both of these binomials would be plus and plus. So we have a 3 and a 1. So you would make this a 3 and you make this a 1. And there's your binomial. It's very simple, and if you distribute it out again, then it would be x times x, which would equal x squared, and then you would have a 3x and a 1x, which would make a 4x, and then you would have 3 times 1, which would equal 3. There's the polynomial that we just started with. So those were just dashes. Don't think of those as minuses or negatives or anything. So that's one equation. So now I'm going to give you an example that you can complete on your own, and I'll show you how to finish afterwards. If I can get this all off the board. Getting off. Alright, so let me think of one that would be easy to do. Okay, I'm pretty sure that factors out nicely, and if it doesn't, then I'll show you what you have to do if it doesn't. So, there's your equation, and I'll give you 30 seconds, or maybe 15, to try and turn it into a binomial. Okay, so if you haven't figured it out yet, go ahead and keep going. But I'm going to go ahead and show you how you actually factor this out. And if my calculations are correct, because I just made up this equation, then it should add up to the answer, which is x plus 12 plus 4. Now, if you have x plus 4 and then x plus 12, like flipped around, it doesn't make a difference. It really doesn't. It just seems like it makes a difference. Really all it does is just changes the order in which you distribute. So, I'll show you how I got these in just a second, but if I distribute these, then I would get x squared, and then I would get a 12x, and then I would get a 4x, which would make a 16x, and then 12 times 4 equals 48. So, that would come out to the original polynomial that I had. So now I'll show you how I got this. Since the coefficient is still known as 1, then it would obviously be known that I need to put a x to begin with on both sides. I'll explain to you why this is, why it wouldn't be this later. So we have a 16 and we have a 48. Unfortunately, 48 has a whole bunch of factors that it can go into. It can be 12 and 4, which we just did, or 48 can factor out into 24 and 2, or 48 could factor out into, what else was I thinking? Oh, 6 and 8. There's a whole bunch of factors that 48 can factor out into 2, and 48 can actually factor out into 48 and 1. So if that was a 49x, then 48 and 1 is what I would have chosen to be my x pluses or whatever. You know what I mean. So, now that we have what we want is the factor of 48, which is 12 and 4, then all we need to do is make sure that it adds up to 16x, which it does, because 12 plus 4 equals 16, duh, and 12 times 4 equals 48. So it does satisfy what we wanted before, so all we have to do is plug it in. Now, if they were asking you what x would be, for this polynomial, then you would have to factor it down into binomials. And the way to figure out what the x value is whenever you factor it down into a binomial is you need to set the binomial to 0.